Welcome everybody. In this video we're going to talk about how to find the inverse of a matrix. And as we've seen in much of mathematics, finding inverses is very helpful. We know how to find inverse functions. You know that when we are multiplying, it's helpful to know how to undo multiplication. We know that when we're adding, it's helpful to know how to do subtraction and undo the addition that's happening, especially when we're trying to solve equations. When we have squares show up, it's helpful to know how to take a square root, or when we have cubes, we want to know how to take a cubed root. So being able to undo the operations that are happening is always a helpful thing in mathematics. We are going to look at kind of a simple example of how to be able to find an inverse matrix by hand. We're only going to actually do the 2 by 2 matrices by hand, and then we're going to for any matrix that's bigger than a 2 by 2, we're going to just have the calculator be able to find an inverse matrix for us. So let's start with a pretty simple 2 by 2 matrix. We're going to have a matrix A, and actually instead of using numbers here like we have been doing, we're going to give each of the components of A a letter. We're going to call this little a, little b, little c, and little d. And in general, if we have this 2 by 2 matrix here, the inverse actually has a nice set formula. By the way, in my other videos, they were pretty up and down. The paper was more oriented like this, and I realized that's not a very good setup, so I apologize for the first few being maybe a little bit harder to read. I've learned my lesson, and we'll switch to the horizontal landscape like this now. So if we have a matrix A that looks like A, B, C, D, the inverse, which we're going to call A raised to the -1 power, this shouldn't be anything new for you. As we've seen, raised to the -1 is the notation that we use for an inverse. When we talked about a function f, the inverse of that function was f raised to the -1. So A inverse, this inverse function, is always going to have a set formula. It looks like 1 over AD minus BC. This is a fraction. This is a scalar that shows up outside of a matrix. So this is not a matrix right here. This is just a number. It's just a scalar that's out front. But then we're going to take this scalar that's a fraction, and we're going to multiply by a certain 2 by 2 matrix, and that 2 by 2 matrix times this fraction is always going to give us the inverse. So the matrix that shows up here is D and A. We're just going to swap their positions. So instead of A being up in the top left, we're going to have D up in the top left. Instead of D being in the bottom right, we're going to have A in the bottom right. And then B and C are going to stay in their same spots, but instead of being positive, they're both going to get negative signs. So negative B up in the top right, negative C down in the bottom left. So this is our formula for the inverse of a 2 by 2 matrix. Let's take a look at an example here. Let's call the matrix A here a 2 by 2 matrix, and let's say that we're gonna have A be 2, -3, 1, and 4. Using this formula, what this means is that A inverse, the inverse matrix, is going to look like 1 over, well, we need A times D, which is 2 times 4, and then minus B times C, which B is -3 and C is 1. So -3 times 1. That's our fraction scalar out front, and then the matrix that we're going to multiply looks like 4, 2, +3, and a -1. Now, let's figure out what this matrix, or what this fraction is when we simplify a little bit. This looks like 1 over, here we have 8 plus 3 is going to be 1 over 11 times this matrix 4, 3, -1, and 2. So our matrix, that's the inverse matrix, is going to look like this scalar, 1 over 11, times our matrix here, which is just going to give us 4 over 11, 3 over 11, -1 over 11, and 2 over 11. So here is our inverse matrix, and notice the inverse matrix is also a 2 by 2 matrix. We won't go into a lot of detail here, but something to keep in mind is that in order for a matrix to have an inverse, it actually needs to be a square matrix. Now when we say square matrix, we mean it has the same number of rows as it has columns. So for example, if A is 2 by 2, then it could have an inverse. If A is 3 by 3, then it could have an inverse. If A was 2 by 3, well, that's not a square matrix, so that matrix would not be able to have an inverse. You need to have a square matrix in order to even have a chance of having an inverse matrix. Now we're going to look at how to find the inverse of a matrix using the calculator, and we're just going to verify that what we found in our last example is actually the correct inverse. So on our calculator here, go ahead and go to your matrix commands. Let's type in matrix A, and you can see I actually already have that typed in, 2, -3, 1, and 4. So we're going to you're going to have that matrix A typed in, and then we are going to find the inverse of this. And this is actually one of the easier commands that we're going to do. So go ahead and go back to your matrix commands, hit A, and then remember that when we talk about an inverse, it's the notation something raised to the -1. So we're just going to hit x raised to the -1 button there, and it's going to give us A raised to the -1, and it's going to give us this matrix. Now, what we just found when we did this by hand is that we got the matrix 4 over 11, 3 over 11, -1 over 11, and 2 over 11. And we're saying, are these decimals the same as the fractions that we found by hand? Well, remember in the last video we had a way to go from decimals to fractions. So if we hit that math button, option number 1 says FRAC, and just hit enter twice, and it will give you the matrix as fractions instead of as decimals. So notice we do still get the same matrix, 4 over 11, 3 over 11, -1 over 11, and 2 over 11. Now, the nice thing about the calculator is not only is it an easy command, but this is also going to very easily and quickly find inverses of matrices that are bigger than 2 by 2. So go ahead and go back to your matrix command, and we're going to type in a matrix B that's going to be a 3 by 3 matrix. And so here's what I have typed in is a 3 by 3 matrix where we have -1, 3, 5, 4, 10, 6, -2, 8, and 7. And so we have a 3 by 3 matrix. So we're going to hit B, we're going to hit the inverse button, B inverse. Hey, B inverse does exist. And so we're going to change that to fractions from decimals. And notice we get some pretty nasty fractions. And so to calculate this by hand would be pretty tough. It would be a lot of work. And our calculator is going to do that very quickly for us. Thanks for checking out this video. I hope that you're becoming an expert in matrix operations and finding inverses.